All right. The second part of this whole thing, graphs are gone. And this is really a calculus, what my calculus kids are doing right now, is evaluating what's the y value doing as we do a lot of different things. For the ones we're going to mess with today, most of it's going to be infinity. All right? To start with, you might see some pretty basic ones, where if I look at infinity and I put it in there, as the t is getting really, really large, I'm going to multiply a really, really large number times -3. So what's happening to that y value? I got death stares. -3 times 100, -300, right? -3 times 1,000, -3,000. -3 times infinity. Negative infinity, right? We've had answers for y's approaching infinity. Algebraically, we can have the same thing. Normally, you're not used to plugging in infinity, but that's -3 times infinity. So the 3 doesn't mean anything, because 3 times infinity is still infinity. But the negative does mean anything, so it's negative infinity. And you will notice, when I click on the box, they give me an infinity thing, and so I'm going to put negative infinity, and boom. All right. Now, one like this. This is where life gets a little interesting. I got a 6 on the top, and I've got 7t squared on the bottom, or t cubed, excuse me. When I plug in infinity, what happens? I'm taking 6, and I'm dividing it by 7 times infinity cubed. So the bottom is really, really, really large, right? So what happens when I divide a number by something that's really, really large? What does it turn out to be? Really, really big or really, really small? Really, really small, right? It's like 1/2, 1/3, 1/4, 1/5. Those keep getting smaller and smaller and smaller, right? So it doesn't matter whether it's a 1 or a 6 on top or what's on the bottom. As the bottom gets really, really big, and I take that and I divide it, I'm going to get 0. Does it matter whether that's negative infinity? It's just now a really, really small but / large negative number, isn't it? So I'm dividing by, say, a negative infinity. That's still going to give me 0. So the answer to this one, I moved it so I didn't move it, 0. Well, how about that one? 10 divided by 7t. Going to negative infinity, right? So the bottom is getting really, really big, but in a negative direction. So 10 divided by something really, really big is still getting really, really small. So that's also still 0. How about that one? Top's 2. What's happened to the bottom? Getting bigger and bigger and bigger and bigger. Still going to 0. Uh-oh, that's weird. But what's the top doing? Just 8, right? Is the bottom going to get somewhere? It's going to get either really, really big, in a positive direction, or really, really big in a negative direction, but it's still going to get really, really big, so it's going to go to 0. How about that one? Pretty much 0, right? Bunch of variables on the bottom, still going to 0, right? Pretty easy so far. Still 0? Ooh, where's that one going? -3 times infinity plus 10. Does this mean anything? Nope. So that one looks to me like that's going to negative. I gotta find my infinity. Negative infinity. All right. Uh-oh. SpaghettiOs. What's going on here? That's going to positive infinity on the top, isn't it? And positive infinity on the bottom. So is it going to 1? That would be nice if they were getting there at the same rate, but they're not. This one's going to do a -5 and subtract 8. This one's going to do a -6 and add 9. So at a snapshot of the same t that I plug in there, they're different. So here's what we got to do. Now, I'm going to kind of show you a little bit, and then I'm going to show you the shortcut. Okay? Here's the theory behind the whole thing. And I'll use t. As I go all the way to the left or the right, the limit as x approaches positive, I use t, so I might as well use t, since they're using t. When this number gets really, really big, what's been happening to it? It's going to 0. So I'm going to use that information to help me out. So, in here, what's the highest power of t? Just t to the first, right? That I see. So I'm going to use a division thing, or a multiplication thing. Whatever I do at the bottom, I'm going to do the top. I'm going to multiply by 1, or divide by 1, because that doesn't change my identity, right? So what I'm going to do is divide everybody by that highest power. I'm going to divide that by t, I'm going to divide that by t, divide that by t, and divide that by t. What that does is turns this all into -5t divided by t is -5, minus 8 over t, -6, plus 9 over t. Looks worse than it was. But it's nice because now I can use this. Because if I take the negative infinity and I plug it in now, I plug it in there, and I plug it in there, these don't change because there's no place to plug the t in, right? What happens to this? 8 over t is going to where? That's getting to be 0, isn't it? This is also getting to be 0. And so what's my answer? -5 over -6, which is 5/6. Pretty cool, huh? Now, let's look at this one, just see. Oh man, is that? Oh crap. Divide by the highest power and see what happens. We'll go with this a little bit more tomorrow, but try that. The G3 is where it's at, okay? And then in the book, same thing. Man, that got here faster than I thought, okay? But we'll finish this up a little bit more tomorrow. I'll probably add to the video a little bit with what we've got. But see how it goes on the part